So to understand self-attention, we also need to understand basic attention. And for this, I encourage you to go and watch my previous videos that covered attention. But I briefly wanted to recap it using this particular analogy, which I find quite useful. And this is also an analogy I didn't actually have in the previous videos, so this might be helpful on its own. I think it's useful to think about attention as really a soft lookup table in a little database. So we've got a database with a bunch of values, entries, and you can think of these as rows in your database. Associated with each of these rows, you have a key that is a unique identifier going with that particular value in your database. And now what we want to do is we're going to query our database using some query vector. Okay, and if this was a classic like SQL database, what you would do is your query, you would just find the key corresponding to that query. It would be an exact match, and we would output the corresponding value. Now what attention does is it's really a soft lookup table. So now instead of the query exactly matching one of the keys, you can think of this as giving you a similarity for how similar is that query to that particular key. Okay. And then what we're going to do, instead of outputting the value that has the key that's the closest to our query, we're going to do a soft addition over all our values based on how similar the keys are to the particular query. So we've got a whole bunch of alphas here, and we weigh each of the values by that alpha value. We add them up, and then that's the output of our little attention block. Okay, so we would have we can start to write out the notation here. We would have an alpha 1 and alpha 2 up to alpha n if there are capital N things in our database. And then we're going to weigh the values based on these alphas and then produce the output. A little bit more formally, you by now know that I like these computational graph way of looking at neural networks. And this is the computational graph for attention block. And what you would have here is just a formal way of writing out what we've already done. We've got our query vector here, and then we've got, you can think of these as our entries in our database, with each entry having a key and a corresponding value, and we're going to weigh these values. And so what you're going to do is you're going to take your query and do a dot product with each of the keys. And with self-attention, we almost always use a scaled dot product. So in these videos, if I say dot product, you can just think of that immediately as scaled dot product. So for instance, we're going to calculate a A1 here, which would be the scaled dot product between the query and key 1. Okay, or you can, if instead of using the dot product notation, you can also just say query transpose times key 1, and because it's a scale dot product, I'm going to divide by the dimensionality of the query and the key. Okay, so the key and the query needs to have the same dimensionality, and we're just going to divide by the square root of that dimensionality. That gives you A1. And similarly, you're going to calculate A2 based on the dot product between the query and now key 2, and then you're going to divide that by the square root of the dimensionality of the queries and the keys. And you go on like this up to, here you've got an. Now this whole thing here is really an n-dimensional vector, right? That has values between, minus infinity and infinity. So we end up with a vector here in n dimensions. And then what we do is we push that through a softmax, and that really just squashes all these values so that they are all between 0 and 1, okay? Which is neat because we want to scale the values, and there are capital N of them. So here you have another vector, dimensionality capital N, with all the values between 0 and 1, and they all sum to 1. And then what we do is we take each of these, so we take alpha 1, multiply it with the value 1, alpha 2, multiply that with value 2, alpha n, multiply that with value n, and then we just sum up all these weighted value vectors. So we get the attention output C, which is then just the sum of the weighted value vectors with each of the value vectors weighted by its corresponding alpha value. Okay, and that's the basic attention block. And nothing is going to change when we look at self-attention. It's still going to be this block. What is going to be particular in self-attention is how we get these keys and values and queries using basically the layer preceding the one that we're looking at the moment. So this is going to be different from the way that we applied attention with encoder-decoder models. The block stays the same, but with encoder-decoder models, we had a particular way of finding the keys and the values and the queries. And now with self-attention, the way that we find the keys and the values and the queries are going to be different.